transversal is a line which intersects two or more lines at distinct points, and if a transversal fall on two lines which are parallel to each other, we get four angles at each point, which consists of pair of corresponding angles, alternate interior angles, alternate exterior angles and interior angles on the same side. For corresponding angles, we have the axiom: if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. And its converse: if a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. Then what about other types of angles? Do we have any axioms or theorems? Let's check it out. Let's see about alternate interior angles. Consider the transversal PS intersecting on parallel lines AB and CD at points Q and R respectively. We need to check if their alternate interior angles are equal. That is, to check if angle BQR equals angle QRC and angle AQR equals angle QRD. We know that angle PQA equals angle QRC as they are corresponding angles. Let's consider it as equation 1. Also, angle PQA equals angle BQR as they are vertically opposite angles. Let's consider it as equation 2. As the LHS of equation 1 and 2 are equal, so are their RHS. So, angle BQR equals angle QRC. Similarly, angle AQR equals angle QRD. This result can be stated as a theorem. If a transversal intersects two parallel lines, then each of their alternate interior angles is equal. Now, let's try to see its converse statement and then check its truth. The converse statement will be: if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. Let's prove this. Here, the transversal PS intersects line AB and CD at points Q and R respectively, such that angle BQR equals angle QRC. We need to prove that AB is parallel to CD. Given that angle BQR equals angle QRC, consider this as equation 1. Also, the vertically opposite angles, angle BQR equals angle PQA. Let's consider this as equation 2. Equating 1 and 2, we get angle PQA equals angle QRC, but they are corresponding angles. So, by the converse of corresponding angles axiom, AB is parallel to CD, hence proved. The converse statement can be also written as a theorem, that is, if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. What about interior angles on the same side? Let's see its theorem and its converse. If a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. Supplementary means the sum of the angles will be 180 degree. The converse theorem is that if a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. Now, let's prove this. Given AB parallel to CD and PS is the transversal intersect on AB at Q and R respectively. To prove, angle AQR plus angle CRQ equals 180 degree and angle BQR plus angle QRD equals 180 degrees. Considering the line PS, we have the linear pairs of angles. Angle BQR plus angle PQB equals 180 degrees and angle AQR plus angle PQA equals 180 degrees. Let's consider these as equation 1 and 2 respectively. Also, angle PQB equals angle QRD and angle PQA equals angle CRQ, as they are corresponding angles of the transversal on parallel lines. Let's consider these as equations 3 and 4 respectively. Substituting equation 3 in 1 and 4 in 2, we get angle BQR plus angle QRD equals 180 degrees and angle AQR plus angle CRQ equals 180 degrees. Hence proved. Now let's try to prove its converse theorem. Given PS is the transversal intersect on AB and CD at Q and R respectively, and angle BQR plus angle QRD equals 180 degrees. To prove AB parallel to CD, it is given that angle BQR plus angle QRD equals 180 degrees. Let's consider it as equation 1. Considering the line PS, we get linear pair of angles, angle SRD plus angle QRD equals 180 degrees. Let's consider it as equation 2. Equating equations 1 and 2, we get angle BQR plus angle QRD equals angle SRD plus angle QRD. Cancelling angle QRD on both sides, we get angle BQR equals angle SRD, which are corresponding angles. As corresponding angles are equal, AB is parallel to CD, hence proved. Now let's work out a problem. In the figure, AB parallel to CD and BC parallel to DE. Find the value of X. Since AB is parallel to CD and BC is a transversal, we have the alternate interior angles. Angle ABC equals angle BCD equals 45 degrees. Let's consider this as equation 1. Since BC parallel to DE and CD is a transversal, we have the interior angles on the same side. Angle BCD plus angle EDC equals 180 degrees. Let's consider this as equation 2. Substituting equation 1 in 2, we get 45 plus x equals 180, where angle EDC equals x degrees. So, x equals 180 minus 45, which is 135 degrees. So, we can conclude that for a transversal on parallel lines, for the alternate interior angles, we have the theorem: if a transversal intersects two parallel lines, then each of the alternate interior angles is equal. And its converse is, if a transversal intersects on two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. And for interior angles on the same side, we have the theorem: if a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. And its converse is, if a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel.